Today, I wanted to talk a little bit about writing single-page apps, reactive web apps in Rust, compiled to WebAssembly, also known as WASM. As a little bit of background, I don't have a background slide like Andy does, but I've been programming for about 20 years. Most of that has been in C++ and Java, with smatterings of other languages. And more recently, in the last maybe 4 years or so, I've been working in Rust. I actually started playing with Rust back in 2015 and actually abandoned it. I didn't really like it, wasn't that impressed with it. And then a colleague reintroduced me to it a couple years later, and this time it stuck. And since then, it's kind of been my go-to language for a lot of things. And it's made programming fun again, in some ways. So forgive me if I get a little too enthusiastic about it, but at the same time, I think it's not perfect, and we'll talk about that a little bit. As Andy alluded to, the learning curve is steep, and it can be kind of verbose in some cases, but it is actually a really good choice if you want your code to be able to run in a lot of different places, from microcontrollers to the cloud to the web browser. And so the web browser is what we're going to focus on today. One other caveat is that I don't actually have an extensive background in either UX design or web application front-end development, and that's going to show when you actually see the application I built here. So just keep that in mind. I am not necessarily current with all the latest developments in the JavaScript and kind of front-end framework world, but I'll give you a short survey, especially as it intersects with the Rust world here. Cool. So agenda today, we'll go through this pretty quickly. First of all, I just want to kind of define some terminology. Most of you are tech folks, and you'll probably be familiar with some of what I'm talking about already, but maybe not all of it. So I wanted to make sure I define some stuff for you. The next is a little bit of a philosophical treatment of how one chooses a programming language, and talk a little bit about why I chose Rust for this project. And then we'll talk about what libraries, frameworks, and tools are available for developing modern web applications, in particular single-page applications. And if you don't know what single-page apps are, don't worry, we'll talk about that. And then I'll look at the case study that kind of got me to this point, which is a photo and video organizer that I built for my family to kind of collect and organize our ever-growing photo collection as we take ridiculous numbers of pictures of our kids and so on. So here we go. So some terminology. Let's talk about web apps first. The fact that you're on this Zoom call tells me that you know a little bit about the World Wide Web. Zoom itself is not really a web app, it's a native app, although I guess some of you could be joining via their web app. So traditionally, back in the 90s, we had these CGI bin executables that got run and would generate HTML dynamically on the server and then send the whole page to the browser. And then anytime you interacted with that web app, it required a round trip back to the server, which would generate a new page, and so on and so forth. And there's still advantages to that. It's still a very popular way of doing things. So just because it's traditional doesn't mean it's obsolete or inappropriate. But more recently, starting in with the Web 2.0 era, the focus has tended to shift towards single-page apps, where you either get sent a big blob of JavaScript, or in this case, WebAssembly, and that's what generates the HTML based on state retrieved via, say, a REST API back to the back end. But all the HTML and CSS is generated on the fly in the browser. There may be some static content mixed in that's not generated dynamically, but hopefully you get the idea. And then anytime any part of the state changes, there's not necessarily a round trip. There could be a round trip back to the server if you need to get data from the server or update something on the server. But anything that only really affects the local UI can be handled locally in the browser without any kind of network activity at all. And then really where the kind of the hot stuff is these days is a hybrid app, because some of these web frameworks have become so big and complicated that JavaScript bundle can be quite large, like on the order of several megabytes. And in order to give you good performance, you can take a hybrid approach where the HTML is initially generated on the server, and then the term is often called hydrated. Once that JavaScript blob gets downloaded, then it becomes a dynamic sort of single page app. So it kind of starts out as a traditional app and morphs into a single page app. And there's other ways to do it also. You can kind of mix server generated HTML with client generated and so on. So there's the whole gamut there, a whole spectrum. And then briefly, reactive programming, you can look it up on Wikipedia, but it's become very popular. It actually predates the web, but it's very popular for doing UI, graphical UI development, because it allows you to declare state and then attach listeners to that state so that UI elements, say buttons or I don't know, checkboxes or what the whole layout of your UI can change dynamically in response to that state changing. And you can have cascading effects where you have some state that is actually derived from other state, and create these essentially a directed acyclic graph of state to listeners, that allows you to kind of represent an app. And the idea here is that when you change some state, you shouldn't have the code responsible for changing the state should not also be responsible for knowing all the different things that need to know about that change. Instead, there's just you set up that graph ahead of time, and then any code can change the state and know that it will be automatically propagated to the parts of the application that need to know about it. And there's millions of examples of this. I'm just listing ones in the web world. This paradigm is actually used for native UI frameworks like Qt and so on. But they're even just in the web app world, there's a lot of them out there. It seems like everybody and his mother, his or her mother, has created one. I was actually tempted for this project to create one myself, but then I regained my sanity. Okay, so WebAssembly, also known as WASM, it's a binary format for executable code. So if you're familiar with lower level software development, you know that inside your computer is either an ARM chip or an x86 chip, probably, unless you may have, some of you maybe have older architectures, but each of these processors has a native machine code that it understands that it can execute. WASM is kind of like that, but it's a bit higher level, and it's intended to be just in time converted to native machine code, but it's the binary format itself is machine agnostic, so it should run equally well on anything that's capable of interpreting WebAssembly on any machine and on any OS. And on the other end, in terms of what you can convert, so that's executing, is basically interpreting the WebAssembly. On the other end, you can compile pretty much any language, whether it's Java or Ruby or Rust or C++ or Haskell or whatever, to WebAssembly. And so in that sense, it's both platform and language independent. And so if you're familiar with something like Java, Java bytecode is a language, more specific language, but also platform independent binary format that was invented in the 90s. And so it's analogous to that, but it's intended to be more language agnostic. and it's useful for running systems code in the web browser. So anything that's very resource intensive, like transcoding video files, or doing physics simulations in a game engine, or computationally intensive cryptography, that sort of thing. But it's not just to be run in the browser. There's a whole industry developing around running WebAssembly in the cloud as a sort of portable execution format, possibly to replace something like Docker, whereas Docker images tend to be very platform specific and more Linux specific, WebAssembly would be more platform and architecture agnostic. And then finally, any questions so far? Sorry, I thought somebody had something. So finally, I should note that although it's theoretically WebAssembly can be used with any language. In practice, it's currently at this stage of WebAssembly's development, it only really makes sense for lower level languages such as C and C++ and Rust, languages that don't have a lot of runtime, like a garbage collector and so on. That isn't to say that you can't have a language with a garbage collector or a larger runtime like Python compile to WebAssembly. It just makes it more challenging, and it makes the deliverable that you send down to the client quite a bit bigger. And there's also some efficiency issues with implementing a high-level language runtime in WebAssembly, which makes it a less popular choice. Usually, you're probably better off just transpiling to JavaScript if you need to run your favorite language in the browser, if it's not a low-level one. Okay, and then Rust, Andy spent a little bit of time talking about what Rust's pros and cons are. I'll just summarize it also here. It's a language that allows you to have fine-grained control over resources like memory and CPU usage, but also things like network connections and so on. The sorts of things that you'd expect to do in a lower level language, but also it subtracts the pitfalls that you would run into in C and C++. And it's pretty well known empirically at this point that even the most talented engineers have trouble writing reliable, which is to say bug-free C and C++ code. There's various statistics out there. Microsoft has said that about 70% of their security defects come from memory errors, which are not possible in Rust, and that's part of the grand promise, or what a lot of systems programmers are excited about Rust for. And so, repeating what I just said, it uses the type system and static analysis to essentially prove that a program is free of these various classes of, unfortunately, very common errors in the C and C++ world, and not just that, but data races as well. So it makes concurrency. That there's a sort of catchphrase in the Rust world, which is called fearless concurrency. And so even in higher level languages like Java, data races are more common than senior software engineers would like to admit. And one benefit of Rust is that it can actually prove at compile time that data races do not exist. So it's not just memory errors. And then built-in support in the tooling for WebAssembly. So kind of out of the box, if you install the Rust compiler, actually you do need to install one more thing as the target architecture to actually get WebAssembly working, but it's one command and then you're ready to go. But then, as Andy alluded to, there is a learning curve, and this is probably the number one thing that's inhibiting Rust adoption in kind of the wider programming or software development community. And it can be summed up that you get the hangover first, and then you get the fun beer buzz. Whereas with most languages, it goes the other way around. Okay, so this is a little bit philosophical, but like Andy said, there's reasons why you would choose Rust. In my case, this was a personal project, and so it was meant for fun, and so I chose the language that I thought I would have the most fun using, which right now is Rust for me. In a more professional context, of course, you'd have more factors to take into account, and I wanted to kind of address that here. The prevailing wisdom these days is that you choose the best tool for the job, which it's good as far as that goes, but of course, what is the best tool for a given job? Well, that can be debatable. I think another factor that you have to take into account is who's on your team, what's their background, how do their what are their preferences and their experience, and how are their brains wired, so to speak. I think that gets less attention by when people debate what the best tool for a given job is, and I think it's equally important. If your whole team is just really gung-ho on Python and it just fits and they're really comfortable with it, it's they feel like it's the most natural language for how they work and so on, then that's the language you should choose. And I think it just sort of speaks to the increasing diversity, or at least what we hope to be the increasing diversity in the software engineering field, that people are going to come from different backgrounds, different educational backgrounds, and so on. And you do want to take that into account as you're choosing a language. Again, in my case, it was pretty simple because it was just me working on it. So, it was Rust. And then finally, if you want to target the web browser, and if you're writing a single page web app, you definitely are, it's going to have to either compile to WASM or transpile to JavaScript, or be JavaScript itself. So here are some examples. Okay, and then finally, let's talk a little bit about doing, the practicalities of single page apps in Rust. There's a variety of, just like in the JavaScript world, there's a plethora of libraries and frameworks out there, even though the Rust community for web development is way smaller than JavaScript. There's still been a lot of sort of innovation and kind of proliferation of this stuff. I'll just name a few here in the kind of Elm/React vein. If you're familiar with those technologies, there's Vue and Seed. You can also, if you're used to just doing framework free like vanilla JavaScript, you can access those APIs directly. All the familiar browser APIs, element dot or get element by ID, that sort of stuff. You're totally free to do that. And generally, any frameworks, just like in the JavaScript world, are built upon the native browser APIs. So one way or another, you're going to be using those. And then down here we have Sycamore and Dominator, and Perseus is just built upon Sycamore to add more features, and the similar relationship with Moonzoon and Dominator. These are inspired by Solid.js. If you're familiar with that, that's maybe a lesser known JavaScript framework for developing single page apps. And its big selling point is there's no VDOM, and that tends to make it more efficient for certain kinds of operations. And so broadly speaking, the Elm and the React style is a bit easier to program in. The Solid style is a bit less easy, but tends to be a little more performant. And the link I had earlier here, if you click on it, will give you a giant table of all these frameworks and compare them performance-wise by a wide variety of metrics. So if performance does matter to you, that's a good resource. And then finally, just as a note, there's several bundlers available. If you're familiar with single page web app development, one of the steps that you do over and over is to bundle your application into basically a single JavaScript, or in this case, a single WebAssembly file, minify it, optimize it, that sort of thing. Bundle in all the resources, libraries, CSS files, and so on, and pack it up for essentially deployment to the cloud or your web server, whatever that is. So I ended up using Trunk. As you'll see, I ended up using Sycamore. I hadn't learned about, I already knew about UNC, and I kind of want to do the VDOM-less style of development. I learned about Dominator after I started the project. Definitely worth a look. It's a little less mature, but all of these could potentially be good choices if you're interested in doing this kind of thing. Okay, and so finally, this is the last slide, and I'll kind of jump over to a quick demo of this app. It's essentially like a iPhoto or Google Photos clone, except with arguably better privacy and a much worse UX, as you'll see. But it's got some neat features, and it fit what I wanted to do. I didn't really want to pay Google or Apple to host the gigabytes upon gigabytes of photos and videos that we've started to accumulate. And so I wanted a cheaper option, and also one that didn't involve me sharing my photos with a third party. So went for a self-hosted option, and what I had found that existed out there, I wasn't really satisfied with, so ended up with this. Here's some technical details. I'm not going to spend a lot of time on that. Feel free to ask questions about that if you're interested. The link is to the GitHub site. You can browse, learn more about it if you're interested. And browse the code if you like. If you guys have questions about and you want to actually see the code, I can do that, but I just wanted to first show the end result here. Let me just log in here. So this is the web app I've been talking about. Oops. Okay, so I apologize. I don't like looking at other people's kids either, but that's really all I have photos of at this point. I do want to point out some kind of fun features shamelessly stolen from Google Photos. My Android phone will, for a lot of the photos I take, will actually take a little mini movie. And so you can get a preview of that for some of these photos. And similarly, if I make a video, you get a little 5-second preview when you mouse over. So that's kind of nice. Let's go to mountains here. So this is just, oops, not mountains or public. I want public mountains. Okay, so I've got a little, I'm glossing over this a little bit, and I don't want to dwell too much on the app itself, but this is basically a way to essentially filter. If you're ever done shopping for stuff, it's kind of similar to the shopping app where, okay, I want a new computer and I want the display size to be a certain size. This is sort of inspired by that, where you can include or exclude by year and so on. Again, the UX is a little bit atrocious, but it does the job. And then we can go through here and we can kind of look at different tags. Let me log out here real quick because I want to show you something else. So I'm logging in with a more privileged account, which allows me to select things. And when I select things, I can, either, select individual ones, and I can add new tags or remove tags. And the idea is to be able to organize them. And it's all based on this reactive paradigm. So, different UI elements get enabled as I select different different photos and whatnot. So basically the experience that modern web app users are trained to expect is what you get here by when you use a reactive web framework. Let's see what else. I think that's really all I had to show as far as that goes.
That's good timing wise. You wanna
cool, perfect.
Just wrap up.
Yep. Any questions?
Actually, I have a question. This is really cool. So I've been working on a new kind of hobby app. So I've been getting into astrophotography lately, and the way that works, you have a camera that records video, but in a kind of weird format that most players don't support. And I kind of started going down a path of building a like a traditional desktop client to show these videos. I'm just curious, like where you show the videos moving there, like is it possible to kind of summarize what's involved there? Like, are you dealing with like drawing pixels, or is this like some library that does that for you?
Yeah, here, let's just a sec. Sorry, let me get back to some examples here just so we can visualize. So the web browser, any modern web browser is going to support a variety of video and image formats. The images here are WebP format, which is kind of like, it's a slightly more efficient version of JPEG, and all modern browsers support it. The videos just use the video tag that was introduced in HTML5, so it's been around for a while now. And so the way this works, like when I'm mousing over, whereas this thing like here that I'm mousing over is just a static image, it's just a WebP image using the image tag. This is actually a video, and when you specify the video tag, you can specify, I forget what the term is, but basically the wallpaper, or basically what image should be shown before the video is loaded. And and when I mouse over, then I have a mouse over handler that basically says, oh, you actually want to play the video now. You don't just want to see the wallpaper, you want to play the video. And then otherwise, the only tricky bit, there's a few tricky bits like, let's see, just a sec here. I don't know if you're hearing the audio here or not, but the other tricky bit is, especially when you have a larger video and with your astrophotography, I'm guessing you want to make sure that your web server can handle range requests, which means it's going to, the web browser is going to try to download a little bit at a time to buffer essentially. And so it's once it's buffered the first part, then it's going to do a separate range request to buffer the next part, and so on and so forth. And so there's a little bit of work if you're using a custom web server, and in some cases I generate these videos on the fly because I transcode them to reduce the file size. In that case, you have to do a little magic to make sure that the range requests work, that a browser request that's coming in may specify that it doesn't want the whole file, it just wants a subset of the file, if that makes sense.
Well, that's super useful, thank you. I will probably need to transcode from this weird format into something that the browser can understand. Cool, thanks.
Yeah, FFmpeg is what I use on the back end, and it can transcode between pretty much any video formats known to man. So that's probably your best bet.
Cool, thanks again.
Yep.
Nice. If you have further questions for either of our speakers, you should be able to get a hold of them through Meetup. I think everyone's on the Tech Confluence Meetup.